Today's lesson is proofs with parallel lines. So we are going to talk about, we have some theorems and the converse of the theorems. So the theorems in general start with, if the lines are parallel, then I have an angle pair, and the angle pair is either congruent or supplementary. So the angle pairs that we're talking about are corresponding angles, alternate interior angles, alternate exterior angles, and consecutive interior angles. So the converse states that if the angle pair is congruent or supplementary, then I can make the conclusion that the lines are parallel. All right, so let's do an example here. This is proving the alternate interiors angles theorem. Prove that if two parallel lines are cut by a transversal, then the alternate interior angles are congruent. Okay, so we're going to write our proof the way that we've been writing them. I can always fill in 3 parts right away. So I can fill in the part that's given. So I've been given that line P is parallel to line Q. So P is parallel to Q. So I can put that in my first statement. The reason I can say, my first reason is given. And I am trying to prove, so proving is what I'm doing. I don't ever use that word, but I'm trying to prove that angle 1 is congruent to angle 2. So I can make that my last statement. Angle 1 is congruent to angle 2. Okay, so right now I see, so I'm going to start writing. So if I know my lines are parallel, then I know angle 1 and angle 3 are congruent. And angle 1 is congruent to angle 3. And I know that because these are corresponding angles. So this is the if part, and this is the then part. So if I have two parallel lines are cut by a transversal, then the corresponding angles are congruent. So my reason is if parallel lines, then corresponding angles are congruent. Okay, so I kind of write it together. So if and then. Okay, then I know that angle 2 and angle 3 are congruent. So angle 2 is congruent to angle 3. And they are congruent because they're vertical angles. So this is the definition of vertical angles. And then, so what I see now is I am repeating angle 3 here. So if I say angle 1 is congruent to angle 3 and angle 2 is congruent to angle 3, I can then say angle 1 is congruent to angle 2, and that is from the transitive property of congruence. Okay. Let's try another example. Same process. So I want to start with, I am given that angle 4 is congruent to angle 5. And I can state that because that is given. And I am trying to prove. So I'm doing the proving, but I don't ever write the word proof. So I'm trying to prove that line G is parallel to line H. Okay, so I know, so I basically want to name what the angle pair is. So it says I know that angle 4 and angle 5 are congruent. That was given. So these are, I also know angle 1 is congruent to angle 4. And I know that because angles 1 and 4 are vertical angles, so definition of vertical angles. And then I see that angle 4 is repeated again. So if angle 1 is congruent to angle 4 and angle 5 is congruent to angle 4, then I can say angle 1 is congruent to angle 5. And that's the transitive property of congruence. Okay, so now I have it. If angle 1 is congruent to angle 5, then my lines are parallel. So this is the if part. This is the then part. Since I started with the angle pair and I ended with parallel lines, then I have the converse because I have the if parallel line. So these are corresponding angles. So if I have two lines cut by a transversal are congruent, then my lines are parallel. So this is the converse of if I have corresponding angles, then my lines are parallel. So this is the converse. So if I have corresponding angles, congruent, then my lines are parallel. Okay, so we have one more theorem, the theorem of transitive property of parallel lines. So if two lines are parallel to the same line, then they are parallel to each other. So if P is parallel to Q, so P and Q are parallel, and I show that by putting an extra arrow on, not on the end. And if Q is parallel to R, so since Q has one arrow, I'm going to put the one arrow on R also. Then P is parallel to R, so all three are parallel. So this is the 1 to 2, and then the 2 to 3. So I can say 1 to 3. Okay, so when I repeat, that's my transitive property. All right, so let's do an example with this. So in the diagram, if P is parallel to Q and Q is parallel to R, find the measure of angle 8. So I know the conclusion I can say is that P is parallel to R. So I kind of not even looking at the Q line, I'm just looking at the lines P and R. So if I know This angle is 115, and it's related to this angle pair here. These are consecutive exterior angles, and they are supplementary. So I know when I add them two together, so this is angle 8 plus 115 degrees equals 180. So I know angle 8 is going to be 180 minus 115, which is 65 degrees. So this is angle 8 is 65 degrees. That's it.